Hello everybody, just doing a quick little video for project number 1. And so let me just try and get this started if I can remember. There we go. Okay, so you guys, for project number 1, there's an online simulation that you'll do. It's pretty simple. But before we do that, I want to go quickly over some key vocabulary. Make sure you got that all clear, so that way when you do the lab itself, you are good to go. Okay, so the first thing that you'll need to know is make sure you know the difference between velocity and speed. Now, this is a common misconception that people have, and I just want to make sure that we are all clear on what these two terms mean. And so velocity is kind of, it includes a vector, okay, and then the rate at which you're changing. And so when we're talking about velocity, we would say, I'm going 25 miles an hour north. Okay, that would include your velocity. That's not only just your speed, but it's also the vector, the direction that you are moving. So velocity is the vector quantity that signifies the magnitude of the rate of change of position, also the direction of an object's movement. Okay, while speed is just simply I'm going 25 miles an hour. Okay, so you can see how these two things are unique. Speed is just simply shows the rate of change in that object's movement, while velocity is showing not only the rate of change, but also the change in direction as well with that. The other thing I want to quickly go over is displacement and distance. So remember, distance is total distance traveled. Okay, so I could say I went from point A to point B, but maybe I took this little detour and I maybe traveled 5 miles. That was my distance. Well, displacement is not the total distance traveled. Displacement is a straight line from point A to point B. So whatever that distance is, that is your displacement. So distance is the actual path taken, while displacement is the quickest path from point A to point B. All right, now this is where some students can get confused, and I want to talk about this. So a lot of people will get acceleration and velocity mixed up. Okay, but understand they are not the same thing, but they do count for each other. So acceleration is just, there's many ways that you can change acceleration, okay? But acceleration is where the velocity changes. So you can change acceleration by either changing the speed or the direction. Here's some examples. So acceleration, this person's speed is accelerating because he is speeding up. He's still going the same direction, but he's just moving in that direction much quicker. And so there, the acceleration is going up. What about this though? Here he is, he's slowing down. So is his acceleration changing? Absolutely, it's going down as well. Yet the direction is still the same. What about this little bumblebee though? It's changing because he's changing directions. The rate at which he's flying is the same. So his speed is the same, but he's changing the direction in which he goes. And so therefore acceleration is changing as well. Okay? So this kind of shows you that right there. We can slow down when we have negative acceleration but positive velocity. Okay? Yeah, and then we can speed up if we have both of those. We can slow down if we have negative velocity but positive acceleration, right? And then we have speeding up, which is negative on both, okay? But according to acceleration, okay? So I hope you understand those. Let's see, why is it not going? Oh, is that everything? Okay, that makes sense. Oh yeah, that was everything. Okay, so now what I want to do is let's quickly pull up the simulation. So here's the simulation that you will be using. There will be a document that you'll have to download. It'll look like this. Okay, and you'll just fill this puppy out and turn that into me. Okay. So when you're playing around with this model, basically there's several things you can do. You can change the position of the individual. Okay, you can change velocity and acceleration. Now with this lab, what you're trying to do, let me pull that back up again, is we are trying to test some different things. So what if we have constant velocity? What if we have constant acceleration? So you're going to look at these two things and see the impact that it has on the positioning. Now the instructions are pretty clear on what you'll do. So it says using the position slider on the man to stand near the tree, give him a velocity of 1.2 milliseconds and an acceleration of 0. So if I was to move this individual, put him next to the tree, okay, and I gave him a velocity, what did it say? 1.2. So I could, and I like to turn this stuff on so I can kind of see it. But let's say I gave him a 1.2 velocity. Okay. And acceleration of 0. Okay. Let's do it again. I'm going to stick him right here. I'm going to type it in 1.2. Acceleration of 0. Okay. So you'll just observe what you see happening over time. The cool thing is you can turn on the chart and it'll actually give you that data of his position. So if I put him over here, like so. Oops, I want to stop though. Pause. Clear. Okay, velocity of 1.2, and I pushed that. What do we see happening? Okay, so you can actually see that occur over time. Acceleration stays at 0. We do have a velocity that's changing. Okay, and so from this graph, if you go up to chart, you can get that data to place right here. You'll do the exact same thing for acceleration, except now making it so that acceleration is changing and velocity stays the same. After you are done, you guys, you'll just analyze those graphs that you saw that are made. You could even paste those graphs in here. So actually, that's what I want you to do is take screenshots of the velocity of each thing. So these graphs right here, I want these pasted in if you could. And anyways, if you have any questions, please let me know. I'll talk to you guys later.